In this lesson, you will learn to solve problems involving angles that meet on the inside and outside of circles. So first off, we have a picture like this, where the angle is formed on the inside of the circle. And notice this angle has its vertex right here on the circle itself. This type of angle we call an inscribed angle, which is an angle whose vertex is on the circle and whose sides contain the chords of a circle. So the sides of this angle, notice the top and the bottom, are chords because they connect 2 points on the circle. And with inscribed angles, the inscribed angle will be half of the arc measure that it creates. So if this arc measure is 50 degrees right here, then this inscribed angle is going to be half of that. So this angle would be 25 degrees. So using that information, we can answer the following questions. This first one, you're trying to find the value of x. So we've learned that the inscribed angle is going to be half of the arc that it creates. So the angle is right here. Oh, that's not too good, but you get the idea. And if we were to connect those two endpoints, the arc that it creates would be right here. So this arc, notice, is half of the circle. So this arc would be 180 degrees, which means the inscribed angle would be half of that, which would make angle x 90 degrees. Here's another example where we need to find x and y. So looking at x right here, this angle, it has that side and then this side. Now if I connect the two endpoints right here and right here, that arc that we create will be twice the angle, or the angle would be half of the arc. So if we add up the 130 degrees from there to here, plus the 90 degrees, that gives me 220 degrees for the arc that angle x creates, which means angle x would be half of that, so angle x would have to be 110 degrees. Now looking at angle y would be right here with these two sides, and if I connect the endpoints of the angle, so right here we would have the arc, and the arc is 80 degrees plus 60 degrees for a total of 140 degrees. So y is an inscribed angle that creates a 140 degree arc, so y would be half of the arc measure, so half of 140 would be 70. So the measure of angle y would be 70 degrees. Now up to this point we have discussed in a previous lesson about central angles, where a central angle has the vertex at the center, and in this lesson we just discussed an inscribed angle which has the vertex on the circle. Next we're going to talk about angles that meet on the inside of the circle. And there's no special name that we give to these angles, but there is a way that we can find the angle measure that meet on the inside. So looking here at angle 1, we can find this measure based off the arcs that angle 1 creates. So angle 1 creates this arc over here, this 60 degree arc, and then the arc across from that, so if I were to extend now these lines, there and there, the arc that is created would be 30 degrees. Now angles that meet on the inside, we can calculate that by simply taking the average of the two arcs that were created. So the 60 degree arc and the 30 degree arc, if we average those, we'll find the measure of angle 1. So if we add 60 plus 30 divided by 2, we're going to get 90 over 2, or 45 degrees, for the measure of angle 1. Now using that same information, let's say we're given the angle on the inside, and we're trying to find this missing arc over here. So same picture, except now the unknown value is the arc instead of the angle. Well, still the same concept, where if I were to average 60 and x, that will equal 50 degrees. So to find the average, I add 60 plus x divided by 2, and that's going to equal 50. So I have an equation here that I can solve by multiplying both sides by 2. So when I multiply the left side by 2, this would cancel, and I have 60 plus x equals 100. And then subtract 60 from both sides, and now I have x equals 40. So this arc measure over here would be 40 degrees. Now we have angles that meet on the outside. So right here, angle x is created on the outside of the circle. And to find this angle measure is almost identical to finding the angle that meets on the inside, where if it meets on the inside, we take the average. If it meets on the outside, we're almost taking the average, but instead of adding the arcs and dividing by 2, we're going to subtract the arcs and divide by 2. So notice the arcs that are created by this angle. We have this arc here is 100 degrees, and then this arc right here is 30 degrees. If I subtract and divide by 2, I'm going to get the measure of angle x. So when I subtract and divide by 2, I get 70 over 2, which would be 35 degrees. So this measure of the angle would be 35 degrees. Here's another example. And in this case, we have a line that's tangent to the circle as opposed to a secant cutting through. And here, same scenario, the angle is on the outside, and we have an arc that's 120 degrees that was created, and an arc that is 20 degrees that was created. So in this case, because they meet on the outside, to find that angle measure, I can subtract 120 minus 20 and divide by 2. When I do that, I get 100 over 2, which is going to be 50. So the measure of angle x would be 50 degrees. Here's one more example where we have two tangent lines, and we are only given one arc measure. So from here to right here, this arc on the outside is 280 degrees. Now we can find this other arc because there's 360 degrees total in a circle. Here's 280. Then right over here must be added to 280 to give me 360. So 280 plus 80 degrees would give me 360. So this arc is 80 degrees. And to find x, I do the same thing where I subtract and divide by 2. So if I subtract 280 minus 80 and divide by 2, I'm going to get 200 over 2, which would be 100 degrees. So the measure of angle x would be 100 degrees. And that concludes our lesson for today. We will see you next time.